Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics, chapter Lagrangian Dynamics, lecture number 10, in which I will solve some problems on Lagrangian dynamics. Now we solve a problem. Problem is a homogeneous rod OA of mass M1 and length 2A is freely hinged at O. This is O. To a fixed point at its other end. This is other end. A homogeneous rod AB of mass M2 and length 2B, length of ABB 2B and length of OAB 2A, is freely attached. This AB rod is freely attached. The system moves under gravity. Find the equation to determine the motion. Now we solve this. Let at time t the rod OA and rod AB inclined at an angle theta and here phi to the vertical be OY axis respectively. Let the coordinates of a point P on the rod OA at a distance r, OP equal to r, from O is xy. Coordinates of point P is xy and the point P is at a distance r from O, OP equal to r. Therefore x equal to, here x be the x coordinate, since theta be the angle made by the rod with y axis, so x coordinate will be r sin theta and y coordinate will be r cos theta. Implies that x dot means dx by dt, differentiating with respect to t, time t. X dot equal to r, differentiation of sin theta is cos theta, theta dot. Here y dot equal to r, differentiation of cos theta is minus sin theta, theta dot. Now velocity v1 of the point P will be given by velocity square, v1 square equal to x dot square plus y dot square. X dot square is r square cos square theta, theta dot square. Y dot square equal to r square sin square theta, theta dot square. We take common r square theta dot square. Here remains cos square theta plus sin square theta, and this is 1. So this is equal to r square theta dot square. This is number 1 equation. Let dr be the length of an small element of the rod OA at P. Here we have a small element of the rod whose length is dr. Since the mass of the rod OA be M1 and length is 2A, therefore mass per unit length will be M1 by 2A. Hence mass of length dr will be M by 2A multiply dr. Here mass of the element. We find kinetic energy of this element. Kinetic energy is half mass into velocity square. Here mass is m1 by 2a dr, here half, and velocity v1 square. Velocity square equal to r square theta dot square. Now kinetic energy T1 of the rod OA, entire rod OA, will be integration of this quantity taking limit 0 to 2a. Here 0, here length 2a. And we integrate this. Implies that T1 equal to, here variable be r, so we take other terms except term containing r. Other terms are half m by 2a theta dot square, and here remains r square dr, integration 0 to 2a. Integration of r square is r cube by 3, limit 0 to 2a. Putting the value of the limit, we get the result 2m1 by 3a square theta dot square. This is number 2. Let Q be a point on the rod AB at a distance r from A. That means AQ equal to r. Let coordinate of the point Q be xi eta. Therefore, we find the value of xi and eta. Firstly, we find the value of eta, that is y coordinate. Y coordinate will be, here we take projection on the y axis, here also we take projection. From this point to this point, let this is r, this is S. From this point to this point, OR equal to 2a cos theta. Therefore, eta will be 2a cos theta plus here angle B phi. So, this is r cos phi. Similarly, x coordinate xi will be 2a sin theta plus r sin phi. Taking derivative with respect to t, xi dot equal to 2a, differentiation of sin theta is cos theta, theta dot, plus r, differentiation of sin phi is cos phi, phi dot. Similarly, eta dot equal to 2a, differentiation of cos theta is minus sin theta, theta dot, plus r, differentiation of cos phi is minus sin phi, phi dot. Let V2 be the velocity of the point Q. This point Q, velocity of. Therefore, V2 square equal to xi dot square plus eta dot square. Implies that V2 square equal to, under bracket, here xi dot square, this quantity, whole square, plus eta dot square, this quantity, whole square, and by expansion we get this quantity, and ultimately V2 square equal to 4a square theta dot square plus r square phi dot square plus 4ar theta dot phi dot cos theta minus phi. Here we have taken common theta dot phi dot. Here cos theta cos phi plus sin theta sin phi is cos theta minus phi. Let dr be the small element of rod AB at the point Q. Then mass of this small element will be, total mass of rod AB be M2 and total length be 2b. Therefore, mass per unit length will be M2 by 2b. Hence, mass of the element dr will be M2 by 2b multiplied dr. Therefore, kinetic energy of this small element dr will be half mass of this element multiply velocity square, v2 square. Let kinetic energy of the rod AB be T2. Therefore, T2 will be equal to integration of this part, kinetic energy of the small element dr. Integration means sum of kinetic energy of each small elements. This is integration. Here we put the value of V2 square. V2 square is here. We put this value and dr last. By integrating, we get the value in theory. Let T be the total kinetic energy of the system. Then T will be equal to T1 plus T2. T1 is 2m1 by 3 a square theta dot square from 2. And T2 will be equal to here from 3. We put this value. This is number 4. Now, potential energy V of the system is given by, since the force acts due to gravity on a rod is at center of gravity of the rod, and center of gravity of the rod OA be at the middle point of the rod. That is, distance of the center of gravity from the fixed end O will be A, because length of rod OA equal to 2A. And since mass of OA is m1, so force acts on this center of gravity will be m1g. Now, this m1g is at a vertical distance OG1 cos theta, that is A cos theta. So reduction in potential energy will be m1g multiply displacement is A cos theta. m1g A cos theta. Similarly, the force due to gravity acts on the rod AB at the middle point of the rod, that is at the point G2, and the vertical distance of G2 will be the vertical distance, means projection of OA on the y-axis plus projection of AG2 on the y-axis, and that is equal to OA be the length of the first rod, that is 2A cos theta, and this is length 2B, middle point is at a distance B cos phi. So this will be 2A cos theta plus B cos phi. This is the vertically downward, that means projection of the distance G2 from O on y-axis. This is the displacement, and force acts at the point G2 is mass of the rod AB m2 multiply gravitational acceleration G, m2g multiply displacement be the reduction in potential energy, that is m2g multiply 2A cos theta plus B cos phi here plus constant. Let this is number 5. We have used the term reduction in potential energy, so we have written here minus V. Now we find partial derivative of kinetic energy T of the whole system with respect to theta dot, and we get equation 6. We find the partial derivative of T with respect to theta, we get equation 7. We find partial derivative of V with respect to theta with negative sign is equation 8. Now Lagrange's equation with respect to the variable theta will be d by dt partial derivative of t with respect to theta dot minus partial derivative of t with respect to theta minus partial derivative of v with respect to theta. We put the value of this and this, and we will get this equation, and after calculation we get equation number 9. Now we find partial derivative of t with respect to phi dot, and this is equal to this equation number 10. We find partial derivative of t with respect to phi, we get equation 11. We find negative of partial derivative of v with respect to phi, we get equation 12. Therefore Lagrange's equation for the variable phi is d by dt partial derivative of t with respect to phi dot minus partial derivative of t with respect to phi equal to minus partial derivative of v with respect to phi, and we put the value of partial derivative of t with respect to phi dot from here 10. We put the value, and we put the value of partial derivative of t with respect to phi from 11, and partial derivative of v with respect to phi with negative sign is from 12 right side. This implies 4b by 3 phi double dot plus 2a theta double dot cos theta minus phi minus 2a theta dot square sin theta minus phi equal to minus g sin phi. Let this is equation number 13. From equation 9 and equation 13 we may determine the equation of motion of the given dynamical system. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.